Hello and welcome everybody to my new video. In the background you can already see the picture I will talk about today. So today we will make a summary about the natural history of the universe, of almost everything. So we start with the universe, but we will end up with the glacials and interglacials of the more recent past. And we will speak about everything between these events. So enjoy. Why do I need so many time axes on my picture? Why isn't one time axis enough? Well, if you want to example show the history of land plants on the topmost time axis, this will only be a very small area around zero. So the history of the universe is a very long history, and many things that are interesting for us, they are happened more in the recent past, and therefore we need different time axes to show them. First, let's talk about the history of our universe and of our solar system. You probably all know that the universe started a very long time ago, 13.8 billion years ago, and the solar system is a bit younger. It started 4.6 billion years ago. But how will it end? What will happen at the end of our solar system? For this, you have to note that the intensity of solar radiation has been increasing steadily since the start and is further increasing, and it will transform in about 7 billion years into a red giant, and then it will swallow Mercury and Venus. Earth will somehow survive, but conditions will become very hostile on Earth, and they will be hostile much earlier, even already in 500 million years. The intensity of solar radiation will be so strong that life is no longer possible on Earth. But 500 million years is a very long time. Actually, it is almost the time that land plants are around on this planet. So we don't have to worry about this future. Let's go back to the start. So the Big Bang was 13.8 billion years ago. But do you know when the first galaxies and stars did form? Surprisingly, this was not very long after the Big Bang, so only 400 million years after the Big Bang, the first stars and the first galaxies were forming. And in particular, our own galaxies, this is almost as old as the Big Bang. So shortly after the Big Bang, our own galaxies came into existence. And what is also interesting is that one turn of our galaxies, one galactic year, um, takes about 210 million years, so 0.21 billion years. That is one galactic year, one turn of our galaxies. Let's focus on the history of our solar system and of our planet Earth, which both came into existence 4.6 billion years ago. And one question you might ask is when did when did life emerge? When did first living organisms emerge on our planet? And surprisingly, at least surprisingly for me, this was pretty early in the history of our planet. So the first microfossils were found about 3.4 billion years ago, but life itself must have emerged much earlier, according to biochemical evidence. So this life itself emerged at a pretty early time point in our history. And another question then which arises is why the land plants and higher organisms in general, so larger organisms, emerged so late in the history of planet Earth. So the land plants are around about like 450 million years ago, and larger organisms in the oceans were around, let's say, 570 million years ago. So pretty late in the history of. And one reason why they appeared so late is the level of free oxygen. Free oxygen appeared only 2 billion years ago. This was Oxygen was produced by these organisms which were responsible for the microfossils by cyanobacteria. They invented the production of free oxygen, and it took a very long time for oxygen to build up sufficient levels that it was appeared in the atmosphere. So 2 billion years ago. And this oxygen is essential for higher organisms because it provides the possibility to gain much energy on the one hand, and it protects against UV radiation from the sun. So, and it took from the first traces of the oxygen to sufficient levels to protect the organisms. It took again considerable time. One last thing I have indicated here on this time axis are global glaciations. So it was interesting to see that there have been times when our planet has been completely frozen, or maybe almost completely. It's not sure whether it has been really completely frozen or only partially frozen, but it was at least to a large extent. Our planet was frozen. This is called snowball Earth, and there were several occasions when this happened in the history of our planet. And these events very likely have been very critical for life. But okay, somehow life apparently survived. So in this first part of this video, I have given you a short overview about the history of the universe and about the history of the solar system. These were very long time periods, billions of years, and now we will focus on a somewhat shorter time period on the last 500 million years. 500 million years ago, that is shortly after the first fossils did show up in the oceans, so there were somewhat larger organisms in the oceans which have left fossils behind. And it is shortly before the very first plants conquered the mainland. So the step onto the mainland was a somewhat longer process. First, there were only very small plants around, and then they gradually became adapted to life on the mainland. This third time axis covers the history of the last 500 million years of our planet. 500 million years ago, that means the first land plants were not already around. They evolved in the following 100 million years and conquered gradually the mainland. So it took some time until they evolved completely. And but the oceans were already filled with large organisms, so they had evolved 100 million years before. So that was the situation 500 million years ago. And let's first focus on the climatic changes during this time. And you can see that there were periods when it was very cold on our planet, and there were periods when it was very warm periods. Um, just let's first ask the question, which factors were responsible for these cooling or warming of our planet? And of course, it's very difficult to find out which factors really were responsible because it's so long time ago. But there are strong indications that carbon dioxide was always an important factor. It was always low when there was cold conditions and always high when there were very warm conditions. And at least in one case, I think it is clearly shown that it was also responsible for this warming because large amounts of carbon dioxide had been liberated in geological events, and they started this warm period. Another important factor determining global climate conditions is the distribution of continents. So always when a continent is either on the south or northern pole, then it is climate will become very cold or pretty cold because this continent then allows the formation of snow and ice, and this will reflect sunlight from the earth, and this will cool down Earth. And this is particularly important in the last 60 million years. In this time, Antarctica was migrating slowly to the southern pole and was isolated from all other continents. And this led to strong cooling down of Antarctica and establishment of large amounts of ice and snow, which reflected sunlight, and this is somehow like a refrigerator for our planet. If you want to take a look at the history of life in this period, we have to take a look at the geological periods that maybe you still remember from school. Each of this period is defined or has been defined by a certain set of fossils which have been found during this period. And it means that each of these periods is defined by a certain set of organisms which have been around in this period. And these sets of organisms apparently changed throughout time. Question is why did they change? And of course, evolution is one important reason. So organisms evolved and adapted to changing conditions. But there is also another factor, and these were so-called extinction events. So it occurred several times in history of our planet that the composition of organisms abruptly or very suddenly changed. In particular, that many organisms were missing from the fossil record, and this is explained by some catastrophes. The best known example for this is the end of the dinosaurs, which came about by an asteroid which impacted Earth 66 million years ago, and which then gave rise to the mammals, which are since then dominating global biospheres. But there were other extinctions events before. Not all are connected to asteroids. Some also are connected simply to climatic changes which occurred and which resulted in dying of many plants or animals on our planet. I shortly want to mention one particularly successful group of organisms, the dinosaurs. They have been around for three geological periods and for 185 million years in total, and have dominated, not only present, but they have dominated biosphere in this time. And 185 years 185 million years, that's almost a galactic year. So it's almost one turn of our galaxies, which these organisms have dominated life on Earth. I've already told you that Earth gradually cooled down after the end of the dinosaurs, and this cooling down became serious 20 or 30 million years ago. And now we are living really in a glacial time. And but if you look closely at this glacial time, you can see that it's not uniform, but that there is a sequence of glacials, very cold conditions, very strong ice shields, and interglacials. And currently, we are living in an interglacial, so under relatively mild and warm conditions. What is driving this sequence of glacials and interglacials? The main reason seems to be so-called Milankovitch cycles, which are irregularities of our orbit, of Earth orbit around the Sun. And these irregularities lead to slight differences in sunlight which Earth is receiving. And these somehow trigger other mechanisms which then result in climatic conditions with very strong differences actually between glacials and interglacials. Another important, interesting point, in my view, is if you look at the time scale. So, one glacial period takes about 100,000 years, and for us humans, this is a very long time. But if you look at the sequence of four glacials, 400,000 years about, this is only 1,000th of the whole period of the land plants, which I have shown you above. And this maybe shows you how which huge periods life on Earth really has taken so far. Since you have watched up to this point, I hope you have enjoyed the video. Next video will be about cyanobacteria. That's the group of organisms which was responsible for production of oxygen in the early history of Earth, so allowing all the other larger organisms to develop. See you then.